Hello AAG students. I was about to post my answer key for our most recent homework with radicals and area and perimeter. So I figured what I would do is just kind of record me going through it, and I'll just kind of talk you briefly through each example. Now I've taken the liberty to kind of just organize my formulas, you'll see, and I've also done the Pythagorean theorem on the next page. But I wanted to go over some simple ideas here. Now, first and foremost, I'm going to find the perimeter of this big green triangle. Now, yes, it's split up kind of into two pieces, but regardless, ladies and gentlemen, perimeter is always the sum of the outside lengths, right? You add up all of the outside lengths. So in this case, I'm not using 3 centimeters. I'm going to add 5 plus 5 plus 8. This is a nice simple numeric example, right? So 5 and 5 is 10. Plus 8 is 18. I'm going to label perimeter equals 18 centimeters. The distance around the outside, not including 3. Now, if I want to find the area of any triangle, this should be a quick, straightforward example. I'm going to have 1/2 times the base times the height. Now, be careful. The base and the height must always meet perpendicularly, right? They must meet at a right angle. So I have a base of 8 and I have a height of 3, so I'm going to just simply replace that here. I am not distributing 1/2. I'm multiplying left to right. So I'm going to do 1/2 times 8, which is 4, 4 times 3, which is 12. Now I'm going to label this with centimeters squared. Okay, so there's our perimeter and area for the first example. Now, let's move on to number 2. I'm just going to fly through these quickly, but remember, you could always pause, take your time, and go back and look at my calculations. Okay, perimeter. Once again, I'm going outside lengths. So I'm going to have 26 plus 26 plus 20. All right, so let's see. 26 and 26 is 52 plus 20 is 72. I'm going to also include my units. Perimeter is 72 centimeters on the outside, not including the inside length. All right, now area equals 1/2 base times height. I'm always writing my formula and I'm always substituting my values below it. You guys should be doing the same thing. The base is 20 centimeters long. The height is not 26, right? Remember, height and base always meet at 90 degrees. My base is 20, my height is 24. 1/2 times 20 is 10, 10 times 24 is 240. Okay, I'm going to label that with centimeters squared. Be careful, okay? You could also do this. 20 times 24 is 480, and then you're taking 1/2 of the base times the height, which gives you the same answer. All right, number 3. Number 3 is a little bit different here, ladies and gentlemen. I want you to recognize why I say that. The height actually lies outside of the triangle. The triangle is shaded in blue here, so the base is down here. So you can see I put my B on here. It's 5.12. All right. Oh, actually, let me go back and just do my perimeter. Sorry about that. So the perimeter is going to be the outside of the blue triangle. So that's going to be 7.13 plus 2.91 plus 5.12. This is only out here to describe the height. I'm not using that in my perimeter. So 7.13 plus 2.91 plus 5.12. All right, now for something like this, I'll just take out my calculator and just kind of plug those in there very quickly. 7.13 plus 2.91 plus 5.12 is giving us, is giving us 15.16. There are no labels on each of the sides, so I'm going to write units. Should you do that? Yes, you should. All right, area equals 1/2 times the base times the height. So again, I'm going to choose my base, which I'm going to use down here as the bottom, right? I'm going to use 5.12. And then my height is not 2.91. Ladies and gentlemen, this is crooked. This is not meeting the base at 90 degrees. So from the tippy top, 90 degrees down to where it would meet the base or the floor, right, is another way to think about it, my height would be about 2.45. Now, from here on out, it's just a calculator exercise, right? So it'll be 0.5 times 5.12 times 2.45. Enter. Now I'm going to have 6.272. I'm not going to round that, right? I'm just going to leave those because there's 3 decimals. That's not too bad. And I'm going to write units squared. Okay, so those are our first 3 examples. Now they're all numeric. There's no algebra, there's no square roots, okay? When we get to the next page, our last 3, you'll notice that on this page, this will involve the Pythagorean theorem, Okay, and then in this case, we get nice whole numbers, right? So guys, again, you can hit pause. Here is my calculations using the Pythagorean theorem. A squared plus b squared equals c squared. So we found out, actually, taking the square root of 1681 is a nice whole number. All right, perimeter, this should be easy, right? 9 plus 40 plus 41. So let's see, and the labels are inches. Let's say 9 and 41 is 50, plus 40 is going to give us 90 inches. Okay, perimeter is 90 inches. Now, let's go to our area, right? The base and height. Now, I'm going to mention this probably each time. I'm never going to use the hypotenuse to find the area of a right triangle. I'm always going to use the legs, because think about it. How do the legs meet? The legs meet perpendicularly, excuse me. So I'm going to have half times the base times the height. And you could swap these, right? These can be switched. But now let's multiply this out. Half times 40 is 20. 20 times 9 is 180, and I'm going to label that with inches squared. Okay. All right, cool. We have 2 more to go. So now the next one is almost the same idea, but ladies and gentlemen, we have a lot of radicals in here. Now, we spent the last day and a half talking about using the Pythagorean theorem with radicals. So what I would do is, if you are not getting 5 radical 3 for this height, then I would hit pause and I would go take a look at that Pythagorean theorem. Okay, but I'm going to push forward and find my perimeter. Now, perimeter, ladies and gentlemen, I'm just going to add up all 3 sides. So that's 5 radical 3 plus 4 radical 5 plus radical 5. Now, I need to ask myself, are all 3 of these radicals like? No, they're not, right? So we do have a pair of like radicals, though. You could see that we have 2 that have radical 5s. Now, don't forget, this is also like a 1 radical 5. There really is a 1 radical 5 in front of that. So there's nothing like with 5 radical 3. I'm going to leave that in my answer. So it'll be 5 radical 3 plus, now here, 4 radical 5s plus 1 radical 5s. It will give us 5 radical 5s, and my label is inches. This is our final exact simplified perimeter. Alrighty, let's keep it going here. So now area is going to be 1/2 times the base times the height. My base is radical 5. My height is 5 radical 3. Okay. Now, at this point in time, guys, I'm going to just reorganize this. I'm going to write this as A equals 1/2 times 5 times radical 5 times radical 3. All I did was put the numbers out in front and the radicals to the right. So what I'm going to do is I'm going to finish this and say 1/2 times 5 is 2.5. And radical 3 times radical 5 is radical 15. Okay? Actually, another way we could have written that would have been, let's ignore the 1/2, right? And then we would have 5 radical 15. And then if I take half of that, I could just put that all over 2. These are equal. If you want to write 2.5 radical 15, I'm okay with that. Okay, that brings us to our 6th and final example for area and perimeter. So I'll get through this and that'll do it, all right? Again, I've done my Pythagorean theorem in the margin. If you are not getting 2 radical 5 as your hypotenuse, then I would hit pause and I would go through this step by step, okay? But I'm going to go through the motions of finding perimeter and area now. So I'm going to have radical 10 plus radical 10 plus 2 radical 5. Again, not all of these are like, but these 2 are. So I have basically 1 radical 10 plus 1 radical 10 plus 2 radical 5. So that'll be 2 radical 10 by putting these 2 together plus 2 radical 5. These are not like radicals, so I'm going to leave them apart. My exact final perimeter, 2 radical 10 plus 2 radical 5 inches. And finally, that brings us to our base, 1/2 base times height, or area formula. Now, something interesting happens here. This is going to work out actually nicely. So my base is radical 10, my height is radical 10. All right, 2 ways to think about this. I'm actually going to wait for my 1/2, but I have radical 10 times radical 10, which is just 10, right? But another way to think about it would be radical 10 times radical 10 is radical 100, and then the square root of 100 is 10, right? So therefore, the area of our triangle is going to be 1/2 times 10, which is going to be 5 inches squared. All right, ladies and gentlemen, I hope this helps, all right? But please remember, ask me some questions or I can meet with you before or after school. Thank you.